Oh, hello.
Hello.
Long time no see.
Oh, is the HTTP working group as well?
In half an hour, right?
Half an hour. Okay, yeah, let
Oh, I don't know which one it is now.
me ask Martin.
No, in the calendar it's 8 to 9, I believe. In the calendar.graphical.org. Do we really have three work groups today? Four.
Oh,
Four.
it's the main one? No.
Four. No, hotel.
Oh my God. Yeah, okay, that's looking different.
Yeah. You know how many people were in the hotel working group?
Yeah.
Was
Hey, Mark.
me.
Hey, Quay.
Hey, Gray. Hey,
Hello.
Mark.
How was Turkey?
Turkey was amazing. We so I learned Turkey's national flower is actually tulip. It's not Netherlands' national flower.
Yeah.
Netherlands' national flower is daisy, apparently.
I didn't know.
Yeah, right. Because like tulips, you think about Netherlands. But anyway, it was like really, really nice. The weather is it's nicer than Paris. I have to like stop by in Paris for like 2, 3 days, because my fiance has a conference there, and then we went to Turkey together. So
And he's from Turkey, oh?
he's from Turkey. He's
Okay.
a
Right.
Turkish person, Turkcey. I think that's the way to say that. I'm not
And
sure.
where in Turkey?
Istanbul.
Istanbul. Okay, so he's from Central. Yeah, my stepfather is Turkish. So.
Oh. Okay, and every time they just like, oh, you need to learn Turkish. It's everything's different, you know? It's a very different language.
It
Every
sounds very hard also from the pronunciation.
Yeah.
Sometimes you
Yeah.
think they are shouting at each other, but they're just talking.
But don't you say that about many languages? Like people say this about us too, and
German?
people say
I
this
think
about
yeah, German is a similar thing. It's like it's something you say as a sentence in English. It's a word with just
Yeah.
many
but
suffix.
that's but
You can combine any
interestingly
word.
interestingly enough, there's that a lot of Europe, northern part of Europe, is from the Germanic tribes.
Yeah.
But Turkish is its own thing. I didn't know
Yeah,
that.
uh,
I was wondering, when they were isolated to develop an own language, but it's its own thing apparently.
it is
Quite
its own
interesting.
thing. That's why vocabulary is very hard. Like
Yeah.
nothing sounds similar. It's like you can't guess anything from anything.
Although the declination tables, they're very similar to Latin.
Oh yeah, the pronunciation is very regular.
Yeah,
Like,
yeah,
right.
yeah.
You see what it's spelled at, and then you know how to pronounce it. So
Exactly.
that was very nice. But yeah.
Yeah, there are more people than I thought.
Okay.
Yeah.
Hello, everyone.
Hey, everyone should, if you have not put your name in the agenda, please do so. And today I actually need a volunteer to be the host because I can only join for the first 30 minutes. Anyone want to volunteer?
Make him.
I'll host. Yeah. I yield to Mark.
Okay. All right.
I yield to Jeff. I think Jeff spoke first now, actually. So
It's a race condition. Like, does anyone has anyone observed who got the least?
UDP
Yeah,
has
I,
its
I, I saw
challenges.
Jeff, but I also didn't look to the side, so
This whole conversation is hilarious.
alphabetical order.
it's just
I'll go for it.
go.
Oh,
I'll take it. All right, folks. I will do that. Let me pull up the agenda here and get us started. All right. So folks. Welcome to the GraphQL AI Working Group. By attending, you agree to the membership agreement, participation and contribution guidelines, code of conduct. The links are in there in the agenda. So please do refer to those on your own. Please do note that this meeting is published to YouTube, the recording, and there are AI summary tools being leveraged as would be on brand for an AI working group. Let's start with intros. Go ahead and we'll go in order here, in the order of the table that's in the agenda. Permalink posted by Mark. Yeah, what's up? Go on.
Sorry, is it I'm the first, right? Sorry,
Yeah.
I'm just
Go
refreshing.
for it. Go ahead.
Making sure
Get us started.
no race condition. Yeah, hi everyone. I'm Kuei. I'm software engineer from Meta, joining from San Francisco today.
And Dale, you're up
Hi.
next.
Hi, everyone. My name is Dale. I'm working at Apollo, working on Apollo MCP server and Apollo skills. I'm coming from Toronto, Canada. And just so you know, like I'm giving a talk in the upcoming Graph conference,
Yeah.
GraphQL conference. Yeah, so I'm very excited.
Awesome.
Michael.
Yeah, I'm Mike
Lorbello.
Lorbello. I work on GraphQL at Airbnb, and I'm in San Diego.
Pascal.
Hey, I'm Pascal, work at Chili Cream.
I'm Michael, working at Chili Cream.
Mark.
Mark from Yelp.
I'll go over to myself. Hi, I'm Jeff Oriama. I work at Apollo, and I'm glad to be here.
Thor, I'm merging your
Nice.
pull request because it has merge conflicts, but you can go.
Okay, sure. Yeah, I'm Thor. I'm a software engineer in machine learning, currently joining from the middle of the Baltic Sea. So I hope my internet connection is stable because, yeah, I'm on Starlink. So yeah, hope it goes well.
Oh,
Crystal clear
nice.
here.
Just you didn't merge well.
Oh, I didn't.
Yeah, I think you lost a bunch of the attendees on the doc.
It's just
Oh, no.
the markdown table.
Yeah,
Lost it.
You know, you just tell Claude to merge.
I should
That's
not
I
do it
I
myself.
submitted early, but it didn't auto merge, unfortunately. It didn't have merge conflicts earlier.
Yeah,
Oh,
it's
I
weird because
did.
you had-
Oh my God.
it's weird that you had problems to ship.
While we're managing Markdown, I think I see some folks on the call that aren't on the attendee list. If y'all can just unmute and introduce yourselves.
Rami Seda from Airbnb.
And I see Arun Kumar S. to be cover you and Prabhakaran. Maybe they're away from computer right now. So let's move on with our agenda. Though this meeting is recorded and automated AI summaries are generated, if if you see anything or hear anything that would merit like manual note taking, please do that. At the top of the agenda, there's a link to our live notes, and it would be a service to the working group to have those available. Don't feel like you got to capture everything, but if there's a specific point that demands some human nuance to it, go for it. Ready for review agenda items is the next item here. There's nothing in the queue here. So moving on to a reminder, there are grants available for key initiatives. If you click the link in the agenda, and I'll go ahead and add that to chat as well. There is a GraphQL community grant program. There are certain guidelines for that, but certainly grants around AI and GraphQL are a hot topic right now and something that's highly aligned with the mission of the foundation and particularly how we show up to meet the moment in AI. So if you can think of something that conforms to these guidelines, that would certainly be welcomed and reviewed by the technical steering committee. And so please do consider that as you make your priorities for the year.
Free money, guys. Free money.
Free money by the foundation, and if your organization will consider being a GraphQL Foundation member, that does help refresh the well of that free money as well. Key community progress updates. The custom embedding model, I think we're turning this over to Thor, if I'm not mistaken.
Yes. Yeah. Okay, so it's my turn. Okay. 1 second. We can share the screen. Oh no, I don't have set the system permissions right. 1 second. Oh, sorry, I need to rejoin the call. Just the Apple thing.
No problem.
1 second, I'll be right back. Sorry. Maybe if someone else in the meantime can do something.
Maybe we talk about Pascal's semantic introspection first.
Can do. 1 second. I think I have everything running now. I believe so. So I just did a talk about this, but I will not bother you with the talk because otherwise I don't have anything to talk about at the GraphConf. We have just released a first version of semantic introspection. And I've showed you semantic introspection here before. What we now have in version 16 of Hot Chocolate is we have disintegrated. And with just one Boolean flag, you're essentially able to now search your schema. Semantically search your schema. So as a refresher, with __ search is an extension to the introspection. You can now send a search query to your server, and then the server will essentially use the search service and this search query and return definitions which match the search that you have provided here. The specification does not specify purposely or on purpose what exactly happens behind this. So everything is allowed. So you can use BM25 if you care about memory. And if you want semantics in semantic search, then you can use, for example, Tori's new embedding model if you want to self-host, or OpenAI's text embeddings or whatever, to embed the search string and then search against the embedded schema. There's a few changes from last time that we looked at it. What stays the same is the paths to root. Michael has graciously done the implementation of this in Hot Chocolate, and while he's done it, he also fixed all the issues in the specification. It was quite funny because I mainly wrote the specification and then Michael did the implementation. That's usually what we do when we do specification stuff. So that's not the one which does the spec, does the implementation, because first 5 minutes in, he was like, why is this called a member? It's not a member, it's a definition. I was like, fair. So this field is now called definition, and it returns the definition of the best matching schema member. What stays the same, but has now much a better description in the specification, is paths to root. We can now, once we know that for this query, we want to see the weather station, we can now take this And we can now, second, here, and fetch the definition. The chances are low that I've typed this right. But let's see. I believe now this should be fields. Yeah. Of course.
Wait, is that?
What? What? There you
Oh,
Oh, yeah.
okay.
So that's just the introspection type, the field type, and now we essentially get the field. The idea is that an LLM first execute this query to figure out what exactly the user wants to see of the schema, and then runs this query to figure out how to how these coordinates which are in the path actually look like. So maybe area by name actually does have a required argument, and therefore we have to provide it. And this is something that we only know when we fetch the definitions, right? Okay, so this is now implemented in Hot Chocolate, and everyone can try it out and use it. What we've also done after this was implemented is we played a bit around with it. And interestingly enough, it solves a few problems that the other agentic APIs have. And one of the problems is that if you have an API the size of Meta, Spotify, or whatever, a company which has an API which is bigger than 10, 15, 20 entities, with
It's not just a meta-size API, right, Pascal? It's just
yeah. I
like
mean, Meta is there is currently nothing that could. There's no way for an LLM to interact with the Meta API. No chance, because it's way too big. So you cannot write an MCP server for the Meta API. But it doesn't need to be a megabyte-sized schema, right? Or gigabyte-sized schema. I don't know how big it is, but it very quickly run into the issue that an MCP server specifically for your API is just has too many tool definitions. We've seen it over the past, I would say, 6 months, even Anthropic has acknowledged this, that it's a pattern that just doesn't scale, because every single time that we do a round trip to the server, we have to pass all of the definitions to the server, because otherwise the server doesn't know that it can call a tool. Similarly, OpenAPI has the same issue. It's a bit better, but still an OpenAPI schema is very verbose, and it gets big very quickly, and you can not really fetch data from you cannot really easily fetch data from this or discover it. So what happened is that there's actually 3 things that an API has to be to work with agents. It has to be discoverable, so you have to have a way to discover the capabilities of this API. This mechanism of discoverability of discovering should be scalable, so it should work for 10 entities, but also for 1,000 entities, and it should be precise. And nothing, neither OpenAPI nor MCP, can actually do these things, but GraphQL can with semantic introspection. Because what we can do is we can say that we have introspection, so we make our API discoverable for the agent, which has the downside that with classic introspection, we just fill the context of the LLM with introspection garbage. So the semantic introspection makes the introspection capabilities scalable, because now it doesn't really matter how big your schema is. If you have a diverse enough entity schema, if you have diverse enough entities, you can very easily fetch specifically what field you want to the user wants to see. And now something which nothing else can do is being precise. We've always made marketing for GraphQL over the years now that it solves the over-under fetching problem and blah, 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 which was fair. But now that more and more people have actually good internet and whatever, this becomes less of a problem than it was 10 years ago. But with agents, we are again there that we have this problem because every single byte that we return or every single character that we return from the API now has to go through the LLM, and for every byte that we send to the LLM, we essentially pay input token costs. So GraphQL is the solution. Now, how does this work? When we looked at this from the agent side, let me clear this quickly. No. Sorry, clear. Last time I presented this, I said that we have an issue because we have an issue because we still needed an MCP, right? We needed an MCP to execute semantic introspection. But that's no longer the case because we can now essentially some case studies. I tried to just create essentially a prompt with a skill for it, and this is enough for us to use semantic introspection, no MCP required. So I can now just go back to Claude, run this, and it will use semantic introspection to discover the capabilities. Yes. And with the search query, you see here, and then it will get the definitions. And then execute the query. And in the end, answer my question, is it safe to go outdoors in Bedok, which is an area in Singapore right now? And how many taxis are nearby? There you go. No, it's currently not safe because the air quality flag is unsafe. And there is 2 taxis available.
So for the demo, like we were at the GraphQL day in Singapore, and Pascal basically put a GraphQL API over the top of the government APIs. They have like a lot of government APIs that you can access with weather data, with taxis, with everything. Like they have this open government initiative. And with that, we basically showed the crowd how easy it is with GraphQL to enable such things in an LLM. Was a really good demo to connect also with the local community, but also kind of showed how much better actually GraphQL could be as opposed to how bloated MCP often is.
Yeah.
You have
And one
to
thing-
come.
Yeah, go ahead.
Sorry, question. Did you have to come? I'm assuming these government are in open API format. Did you have to convert them into a GraphQL schema first?
So the funny thing is that these government APIs do have nothing. The documentation that they have is this, and they have the API specs, and some of them are open API, some of them are not, I believe. Yeah,
Horrible.
but we had to convert them to GraphQL first.
To GraphQL. Okay, yeah. You just added a layer. It's
Yeah.
mostly one-to-one mapping, right? Not a big deal. Yeah.
Yeah. I mean, this is quite simple. This was quite simple. One thing that I want to point out now is that so we created a gateway here where we have these downstream services, right? Which this is just part of the Singapore government data. They have like 3,000 APIs. It's crazy. So they have 3,000 open API documents that you somehow have to merge. And then the next problem is that you have to figure out which API you want to call. And with Federation, you don't have this problem. And that's quite beautiful, right? Because you essentially have one We have one query that we can execute, and behind the scenes, it's actually going to, well, not this one, but for example, this one goes to multiple APIs, right? And for the LLM, so before I don't know 2023, we said the consumer. Now we say the LLM. It's very easy to not to discover these capabilities, because there's no different endpoints to call. There's no different open API documents to scan or something like this. It's really just one schema that you can query and you can fetch data.
It's even better. Like if you think about all the tools that you can have also locally, you could put one GraphQL layer over the top of that, and then the LLM just asks for the tools it needs, and the layer basically says, okay, I have a tool for you here, which doesn't pollute the context anymore. With all the tools that you say you want to have the context there, but which might never be used.
What's additionally quite interesting is how well this works. We were a bit surprised ourselves. This schema is not huge, right? It's just 260 lines. You could easily fit this into a context window. And for the embedding models, we by default, as this is the most CPU memory efficient one, we just use BM25, which is not an embedding model. It's essentially just best matching search. But the thing is that we cannot run a local model when you install Hot Chocolate for all of our consumers, right? That's not going to work. So by default, we opt for this BM25. We allow our customers to also override this with whatever they like, if they have local models or whatever, or they connect to Nitro and then just use some text embedding model we use. Yeah.
Yeah, one interesting idea Pascal also came up with is that with this, actually what becomes more interesting is namespaces in GraphQL.
Now you open the floodgates.
because if this it's a 10x better in tokens, right, than other API variants, and it becomes even better from the efficiency, like 20x, 30x, the more tools you have. And if you use GraphQL as a layer over things, you could also just put in, just have it as a layer over tools that are not interconnected like you would do in Federation. But then you have problems with type collisions and stuff like that. And then something like namespaces actually could provide the capabilities that you can co-locate all these types in the same schema and make them queryable for an LLM, just as a side experiment.
On that note, who remembers this? Hey, what was it?
Yeah.
H4S
or
Hypermedia as the engine of application state. Yes. Who remembers this? That was like, I don't know, 20, I don't know, ages ago.
You're revealing your age.
Like the web, was this Web 2? I can't remember, but it was sold as the thing, like that now in the web we will have hypermedia and websites will link themselves to other websites, and then crawlers can discover all of the knowledge which is in the internet and whatever. And it never happened because no one could care less, about actually connecting the web. But with namespaces, this becomes very, very interesting, because with namespaces, we can federate, merge, stitch, whatever, any API that you want. We can take GitHub's API and we can merge it with the Shopify API, just like that.
Yeah,
and there's
they're
no
in this case not interconnected. I mean, you could get them interconnected, but
Yeah,
you
but
basically
that's where the hypermedia comes into play, because that's where you can do the connection. You can now say that these are not connected, but you can reference a type from the other schema over a namespace, and then you can suddenly connect two completely different APIs together. And that's quite interesting.
What is it?
Any questions?
Just on suggestion, similar suggestion. So I saw you copying I mean the like multi lines of prompt
Mhm.
in the chat. So I feel like this is a really good use case for agentic skill, like agent skills. So if you could provide a like companion skill, people just can install it and then they can start, with their, question right away without the pre-instructions.
Yes, yes. So that's the idea. For this, we probably need another server which supports semantic introspection. But you're right. Like it's very simple. It's just some description that we can put into an agent skill. That's right. Anything else?
Yeah, I have a question about the benchmark. Pascal and Michael, you guys mentioned that this approach is kind of 10x or even 20x better. I'm wondering, maybe a more realistic comparison is the CLI approach where like the model actually do grep. I'm wondering I don't know if you're gonna still see that much of a win, because I sense like grep is kind of especially with the if you convert that government API into CLI format and have the dash help which list out like the subfields so then the model does that discovery itself. I just wonder if you want to try
So
see how it works.
I would say, now I'm just leaning out of the window, but I would say that it's probably still going to perform better, because I know the CLI approach. I have issues with
In your
it.
blog post, you mentioned it, right? Yes, we definitely.
Yes. So the CLI approach, my problem with the CLI approach is that my mother doesn't have an idea what a terminal is. So she's not able to use the CLI approach. But she's able to press add in ChatGPT to add an MCP to the chat window, right? So the CLI approach it's much more difficult to access. So if we have APIs which support semantic introspection, it would be actually one feature that has to be implemented or just an agent skill that has to be provided by Claude or OpenAI or whatever. And you can suddenly talk to these APIs without having to have a terminal or a CLI. So that's one part. The other part is with the CLI, if you just take the endpoints and you map the endpoints, what you end up with is that you can now successfully discover the API, and you can also most likely make it scalable if you nest it enough, right?
Yeah.
If you have now this API that is discoverable and scalable, you still, just for record, with semantic introspection, you need two turns. You first do a search, and then you do a definition fetch, and then you can fetch the data. And that's quite crazy because we can search from multiple endpoints in this government API, because weather API comes from weather data comes from the weather API, and taxi data comes from the taxi API. But it's only three turns, ideally. It's search, definitions, execute. And that's a thing that I would say probably if we convert it to a CLI, it would still take more turns.
Because it's gradual, right? Every step you do.
And it's not interconnected, or you have to generate basically a purpose-driven CLI. So the model would need to generate a CLI just for a model to consume it. The other thing is with CLI, you also, like with GraphQL, you also have the other advanced, like the other thing that you can just say what you need. Like the model can just specify, I need this kind of data from actually the GraphQL model, and then it just consumes this part. With CLIs, it's often like with REST APIs, where you can invoke a command and then you get a fixed payload that the CLI thinks is there. I mean, it's all solvable. You can really build purpose-driven CLIs for each use case. But then you have an explosion in CLIs.
There is one funny thing. In my other demo of semantic introspection, I use a CLI. I use the GitHub CLI. And what I do there is I use semantic introspection to generate the query for GitHub. And then I use the CLI to execute this query because they have the GH space API where you can just paste any GraphQL query. And this solves all of the authentication authorization problems, right? Okay. Any other questions? Cool. Otherwise, shoot me a message in
Great
Slack.
discussion.
Then, Thori, stage is yours. You're muted.
Still muted? Can't hear me?
No, we can hear you.
You're good.
Yeah, can you hear me? Oh, okay, great. Okay, can you see my screen also?
We can see your screen and hear you. Yep.
Okay, sure. That's great. Yeah, hello everyone. Yes, I was looking into like fine-tuning embedding models because as Pascal already mentioned, like semantic introspection is quite valuable. And the difficult part is like how well can an LM like formulate like queries if it doesn't know the schema. And so here the idea was, okay, can we take like an off-the-shelf embedding model and improve its capabilities on recall? So if an LM can like recover or just call your MCP server, you have the abstraction on the vector search probabilities, and you can have a really good ranking. So you have a search query and you get the direct maybe type field coordinates or the direct type recoverability. So the idea was, can we improve like the ranking stability? And yeah, so this is just based on the Qwen 0.6b embedding model. So it should be real small, so it can also run on like CPU inference. And so this was specifically tuned to have like this ownership differentiation, because if you like search for maybe an author, the author could be like in a pull request or could be in an issue. So the LM, or in this case, the embedding model doesn't really tell those apart. So it was like trained on if you have like multiple fields on like different types that have the same name to better differentiate between those. And so how this was trained is like I generated like a data set on like syntactic questions, so natural language questions paired with like related types and fields, and like negative pairs, generated close by. So that's like really hard for the embedding model to differentiate between them. To generate a test and validation data set, which was on like synthetic schemas and also on real-world schemas. So basically built a seed world of like 60 different schemas, and then an LLM formulated like natural language questions and built like the best matching pairs. And then it was trained to better distinguish between those. And like, so I published this on like Hugging Face, and like the results like compared to baseline is basically, quite an improvement, because it can now better differentiate between different types. So maybe one example I could give. So an easy example is, okay, so a user question, so natural language question is, what's the nightly rate of this room? You have like different types that might explain this. So this is the base model ranking and the fine-tuned model ranking with the same field price sense occurring in all the types. now better ranks this this room type as the first match. So it's like improving the ranking recall so that we could choose a lower top K and get more accurate results. So this was the idea. Yeah. So questions so far, I don't think. Yeah, Mark.
Yeah, this is really cool. And I have a clarifying question, and then I have a follow-up question, which I just kind of thought of, and maybe it's also applicable to semantic introspection as well. But so my clarifying question is, I'm a little bit naive about this, but if you want to do scanning over a schema and it's really, really large, it's going to fill up the context window, same problem that semantic introspection is solving. And so if this is sort of like fine-tuning a model and you're doing like embeddings into the model, does that like can you deal with like a massive large schema basically? And like how does that help is the clarifying question.
Yeah, I think the question is if this like maybe generalizes so out of distribution of the training distribution, maybe because you don't want to fine-tune this on every schema. So the idea is that you have like a model that is specifically tuned on like the way GraphQL works, on like hierarchy levels work, on type field levels. And yeah, the idea is it should scale to different schemas as well, because you would just generate vector fields and you just have cosine similarities. So basically how closely aligned are those vectors? And so this should scale to all kinds of schemas, I would say. So at least this is the hope of it,
Okay. And then my follow-up question is another direction that I would love to see this go in, and it's like very relevant to what you've done here, is a problem that I think we and a lot of other people have is we've put a lot of auth inside of the GraphQL schema. So like private, protected, auth, requires, whatever, like all these directives that exist in a whole bunch of schemas and are implemented in a whole bunch of frameworks. I think it's neat, but having an LLM be able to scan your schema and say, hey, you missed, locking down this field, or you applied the wrong scope to it or something, and using the schema, like looking at the description, looking at the fields, looking at how it's queried, like maybe if you can look at the source code as well, that's kind of a different thing. But basically, being able to like do that, like inside the like as an embedded thing, I'm not quite sure. But yeah, I'm wondering if basically this could be extended to looking at directives on bits of the schema and sort of asking the question like, does everything have the right permissions directive applied to it, something like that. Do you think that's like a related direction that this could take?
Could be. I mean, this is in general like mostly for assisting LLMs, like you said, like with lookup or like with semantic inspection. So I mean, generally you could. So what you do give to the embedding model, the text you would say to embed, could be anything. So you could also put directives in there as well. So I mean, if you have like a search string query that would also maybe contain a directive specifically you are looking for, it should fetch those in the top K maybe as well. But I haven't looked into how well this would work. But yeah, could be maybe an approach, like a search approach for an LLM.
Yeah, I'm wondering if like there was like a spec'd out standard set of auth directives, and like policies or whatever, and like that was something that you like ran fine tuning on, so it could like know to flag those things.
That's like solving a non-deterministic problem with a deterministic problem with a non-deterministic solution, right? So
I agree.
I know exactly where you're coming from because I have similar ideas about application, not on the schema level, but on application code level. That you actually should have skills specifically for certain tasks and that they verify that you didn't mess up authorization because it's very easy to miss. But you could just run it on the diff, right? So you could just run it in the PR on the diff of what you have done, and then you don't really need the full text embeddings lookup. Because
Right,
like
that's the thing
essentially
that you can do right now without any of this, and the thing that we kind of try and do, which is like, here's the diff of the PR, here's the diff of the schema. You've got access to the source code as well. Just like shovel that into a prompt, and like go have fun. But again, you're kind of getting into potentially, I don't know, context size issues, because like this bit of the schema might actually relate to this other bit of the schema if it's like a nested field or something, and the cascades and whatever. It's like
I mean, I may
this field doesn't have permissions on, but like the type 3 levels above it did, and so you kind of need to know that, and that's not in the diff, right? So you kind of need to potentially look at other parts of the schema.
I might have missed something, but this is an embedding model that yields a vector for whatever I embed, right?
Yes, exactly, like
That's
any
the
other
normal
embedding
embedding
model.
model.
Yes, yes.
Yeah, okay. So that it's more for a needle in a haystack search, right? So you want to search for this is exactly what we want for semantic introspection.
Yes, exactly. That's what it was tuned for. Yeah.
Yeah, it's
So
one-to-one this search. Whereas I wonder, like, I don't see how to make use of this in the case of Mark's question. That said, how do you embed, or how did you fine-tune this? Is this something like I have no idea about model fine-tuning, so I
Yeah.
probably ask very stupid questions
Yeah.
now.
Yeah.
But is there something is there a way that you showed the model how a type hierarchy works or something like this, or is this something that you just had trained into based on repeating training data?
Yeah. So it learns this implicitly. Yeah, that's true. So how you would train it is, so in this case, you give a natural language question and you give positive negative pairs, and it tries to, in this hyperdimensional space, relate positive concepts closer and negative concepts farther away. So this is the train loss objective, basically. And the model implicitly learns how to best approach this, giving it like, so I gave it like 5,000 examples over like a couple of episodes, a couple of training epochs, and it learns basically the schema hierarchy, but it doesn't know in each batch the full schema. It just knows the question, which concept would relate and which concepts might sound similar, but are kind of ambiguous, but not truly related to the user question. But it can't never really truly know the full schema in one training run. Yeah, that's true.
Yeah. I wonder what we can do. Like, so you essentially the vector, the input that you embed is the coordinate, right?
Yes.
So I wonder, like, this is really good because this is exactly what we need for semantic introspection. I'm super happy that this exists now. That's really great. But my additional question here is, there is in GraphQL with these hierarchies some interesting things where a coordinate actually only really makes sense in the context of a parent and the parent of a parent, which also goes a bit into the thing that you mentioned, Mark, where you have an authorization which is 3 levels up. And with just classic like embedding of a schema coordinate, you obviously don't get there because it's very, local. Is there in the world of embeddings, because you definitely know more than I know about it, is there some way to have these relations? Is this really would we just have to embed a different input string for it?
Yeah, it would have just a different input string. So it's basically flat, like what you would say. Yeah, it's like a flat hierarchy embedding. You don't really have hierarchies in that sense. So you would layer that maybe in a logical step on top. You may do it like on a 2-pass step. You pass one embedding and then the other, like maybe first look up the first level and then the second one. Or you could go in one go and see how well it works. I mean, you could try and see how well it abstracts to this, but I haven't looked into this, so might try that out.
So if we just now are a bit crazy about this, how would things work if essentially just pass in a text? There's
Yeah.
Nothing,
Yeah, exactly.
nothing
That's
like
what embeddings is. Yeah, so you can
right.
pass any
So
text to it.
there's
Yeah, yeah, yeah,
so technically
yeah,
we could
yeah.
also say that there's like three coordinates in this direction, three coordinates in this direction. What's higher up and what's below, and then if we specify how this training data looks like, you know, the positive coordinate that you have in here,
Mhm.
and we would provide the same kind of specification for the actual operational use, then you could kind of get these semantics in, maybe, you know, that you say that actually, you know, there's some kind of probability that the parent of this field and the child of this field may influence your decision. And then there's a lower probability that the grandchild and the grandparent influence this decision.
Yeah.
But maybe they do. And then I'm
You
just
could
wondering.
maybe see if you could have two input types, so two input queries, so you would relate maybe the two hierarchy levels maybe in the training as well. I'm not sure if that would be possible, or you would do it in like two passes, like I would say. You would do one pass on the higher level and one on the one below. Yeah.
How big is Qwen 3?
Yeah, this is just the 600 million parameters, is quite small. So this is like less than 2 gigs of VRAM, so you can also run it on CPU or on Edge. So this was the idea. Yeah.
That's really cool.
Yeah. So you can also try it on your local MacBook as well. So I also included the Python transformers. You can just try it out either directly in Python or via Llama or Llama CPP.
How
This is
big
more
is the
experimental. Yeah.
how big is the
weights.
how big is the model in storage terms?
You have different quantizations. So if you do a floating point 16, you have 1.2 gigs, and Q8 650 MB. I haven't tried Q4 quantization. It's quite small. I'm not sure how well accuracy preserves there. But I mean, you could go around 600 megabytes with Q8. This would be ideal.
That's very cool.
Yeah.
That's very cool.
Yeah.
I'll give this a spin. This
Yeah,
is
sure.
really, really nice.
Should try. I mean, the vision would be if this could be done totally on client side, if one could go even smaller. I mean, would love to try that out if one could distill the model in like 1/10 the size, if it would still work. But I mean,
So
might see how crazy it can go with this. Yeah.
I've had a discussion with some engineer from OpenAI the other week, where I said that what kind of is missing for a lot of use cases is that the LLM could provide you an already embedded string, because otherwise what happens is that we have to pay it on the edge, right?
Yeah.
So every time that someone does a semantic search, I have to pay for the embedding.
Yeah.
And if I use OpenAI or Anthropic, I actually pay money. It's not much, it's very cheap, but I cannot use the bulk API, so it's gonna cost a bit of money. And running it on the edge with these local hosted models is definitely something I'm gonna try, because that makes it a bit cheaper to operate.
Yeah, it's really cool because there's just off topic if it's too long, but it's Transformers.js. So there's a JavaScript binding for mobile clients where you can run ONNX models directly on client side. I mean, it depends on how well the compute of the client is and how many gigs they want to download, but you can, the same implementation you could run in JavaScript. It is already ported. So I just need to convert a model to ONNX, so it should run on client side as well. I mean, this would be like a cool vision to see. Yeah. To see.
Yeah, this would then essentially save the indexing would still have to happen on my side, but and unfortunately the models have to match.
Yeah, the models have to match, but the request could be from client side already embedded. It would be cool.
Yeah, that's cool. Very exciting. Thanks.
Really cool. Thank you for sharing, Thor.
Yeah, thanks.
Any other questions, comments?
So I mean, if there's some real world feedback or like real world applications, I would love to hear about. So in the future, we would try it out. Just notify me. Yeah.
Definitely, we'll take this back to the team for sure.
I'll let you know how it went.
All right, folks. Well, that's the end of our planned agenda. We have about 6 minutes. If there are any brief updates or items to share, otherwise we can adjourn.
I'll just kind of quickly enter it onto the record that I was speaking with Michael in DMs, the mock spec that we were talking about last time or the time before. I've been on PTO for a few weeks, but I'm back at it now, so I'm still planning on merging that as a gap as soon as I get a chance. So no real updates.
Awesome.
Close the gaps.
Yeah. All right, everybody. Well, let's adjourn. Thanks all for your attention and time, and for our presenters for all their great and innovative work. We'll see you next time. And just a reminder, if you're planning on coming to GraphQL Conf, we'd love to see you there. Have a good afternoon, or whatever time of day it is where you are. Later.
Thanks everyone. See you then. Bye bye.
You.